So we're reviewing for the quiz. Here's the 3 topics that we need to go through. Trees with givens, expected values, and triple Venns. On your scratch paper, follow along with me, and I'll ask you to do some stuff here and there. Here's the first part. I've got a tree already made, and it's got some, I'm going to ask you some questions saying given, and see how you do. All right, this is let's say this is cats, and let's say that it's blue cats and gray cats. Let's say that for some reason when these mommy and daddy cat have baby cats, they have either blue ones or gray ones. Instead of boys and girls, that way we don't have to make boys better than girls or girls better than boys. It's blue cats and gray cats. And I can tell you why I picked that. I have cats. I have 2 of them, and they are Burmese cats, and they are actually classified as blue. It's a strange tint kind of to their fur. And anyway, there are different tints that the Burmese can have, and they're expensive little cats. I got them used, so to speak. I got them from somebody. But if you buy them new, from a breeder, they're like $700. And because the blue ones, that's kind of a desirable color. And would you agree that blue would be more unusual than gray cats? Okay, so we're going to do an expected value with this too. But first, I just want you to use the chart I have and answer this question. Given that there were 3 cats born and they were individuals, okay, this is kind of unusual, but let's just go with it. If I say it's given that it was a girl cat first, what's the probability that it was girl, boy, and oh, sorry, I'm saying girl and boy, gray, sorry, and blue, and then gray. So given gray cat, I did it with girl last hour, gray cat first, then what's the probability of gray, and then blue, and then gray? I'll pause while you finish that. So we've gotten it this far. We've got 0.51 on the bottom because these are the things that are possible, and we added them all up and put them on the bottom here. And the things that were given, the things that we wanted, the GBG, is on top. Divide those two, final answer. 0.25, 249, 250. It's probably just a rounding thing. All right, so to answer the question in real words, it's about a 25% chance that that would happen, given that the the gray cat is born first. All right, next thing. If I'm going to change this to an expected value problem, what's that little formula I keep telling you to remember? P times A, then add. Very good. P times A, then add. So we've got our probabilities here, but we don't have any amounts. All right, and then you would add them all up. So if I'm just going to try to do this for, let's say, the blue cats that have a blue tint to their fur, get $700 for them, and the gray cats, let's say that since they're much more common looking, they only get $300 for those. So if I was the one who had these 3 cats and I was going to sell them, the one that would be the most profitable for me is this one, right? Blue, blue, blue. And so I've got a probability. Now I need an amount. What amount would go with blue, blue, blue? 2,100, because it'd be 700 plus 700 plus 700, right? 2,100. All right. Let's finish this one together, and I'll pause the tape so while we finish it. Okay, so now I've got all my my amounts from how much I get for each one. This one, for instance, was 3 girl cats or gray cats, so it's 300, 300, 300, makes 900. Now I got to do P times A, and then I'll add them all up. So we got to do this times this. We'll put it here, and then we're going to add all of these up and get a final total, and we'll talk about what that means in a second. All right, I'd like you to help me do this again, and we'll pause it while we do that. Okay, so we did our probability times our amount, and we got this, and now we're supposed to add them all up. So we added them all up, and we got $1,485. What in the heck does that mean? Toshi. That's the average value for the 3 cat combos. It's kind of what I could expect to make if I was going to sell the cats. Okay, and it also factors in the probabilities being that I'm more likely to have gray cats than blue cats because of that. All right, so that is a complicated expected value, but they always boil down to P, then what? Times A, and then what? Add them all up. Okay, good. And what you're getting, I like to call it an average expected value instead of just an expected value because it's kind of an average of those. All right, this last piece, I'm going to do a triple Venn for you and see if you can figure it out. The triple Venns, they'll give you a bunch of information and you have to figure it out. Right now, try this on your scratch paper. Draw 3 circles that all overlap each other. On your scratch paper. Mr. Rose, thank you. Would you please tell me if there's an 8 in the middle there, what does that mean? Mr. Rose? Yep, those are people that have cats, dogs, and fish. All right. And what do I mean by this 10 up here? Does this 10 mean that there should be a 10 in the blank right there? No. When they tell you that, when they tell you there's 10 cat and dog people that have cats and dogs, you can't just slap it into the chart. You got to figure out what goes where. If there's 8 in the middle, what would have to go here? 2. Get the idea? Keep going just like that and see if you can complete this chart. I'm going to pause while we finish it. The question came up, I didn't say how many people had just a fish. And you can figure that out because of this number right here. I did tell you that there's nobody in the neither, which means that everybody I pulled had either a cat, a dog, or a fish. And that means once you figure out all those numbers, they have to add up to 100 here. 100 people pulled. And so that's how you can figure out that last number for fish. Again, I'll pause to give you more time to work. All right, go ahead. Did you start with that number? I believe you there's 7 there, but I bet you figured out something first, though. Just kind of do it in the order that you figured it out. All right, dogs, fish, where they overlap is right in this area here. Put 1 there because 8 plus 1 has to add up to 9. Excellent. Okay, now what? Fish, cats, 3. 8 plus 3 makes the 11 here. Okay, good. And now we can do that cat one. You said it was 7? Because all of those numbers, 7 plus the 2 plus the 8 plus the 3, have to add up to 20, and it does. Good. How about the dog number then? 19. That works. I remember that number. And then I go 8 and 1 and 3 plus that has to add up to the fish. Wait a minute. I don't have the fish. How can I do this now? Add them all up. And when you add them all up, I bet it added up to 40. So that means there were a lot of fish lovers in this survey. Lots of them. 60. This must have been a poll at a magazine that like mostly catered to people that own fish. That would be a way it could be biased that way. It would definitely not be like a poll of a random sample of kids here anyway. Okay. So now you'd be asked a couple questions about the Venn after you've made the Venn. All right, so here's a given kind of question. Given that the person I pick is going to have a fish, what's the probability that they also have a cat? Given that they have a fish, what's the probability they'll also have a cat? Give me a second to work. This started. How'd you get the 72 on the bottom? I agree with you, but how'd you get it? All of these added up because why? Yes, they're all the only things that are possible, people that had fish. All right. The possible goes on the bottom. The favorable, or the thing I want, goes on top, which was cats. And it's really easy to see. I bet some of you had 3 out of 72. Anybody willing to admit it? All right. Thank you for being bold enough to admit it. Do you now know what it should be?